Okay, in this video, we're gonna exploring how can we use the solver to solving the transportation problem. So if you haven't watched the previous video, make sure you watch it because we already identified decision variable, the objective function, and the constraint. So the next step is we're gonna put everything on my Excel. Okay, so let's put everything on Excel. So we're starting from a blank Excel spreadsheet. And of course, for this case, you can set up your first table 1, and then is the parameter. And then as we know, we total have 12 choice variables: x11, x12, x13, x14, x21, x22, x23, x24, x31, x32, x33, x34, right? So we have total 12 choice variables. And then the only parameter we identify is related to the cost per unit. Okay, it's a good idea to write it down so that we can avoid making the mistakes when we are trying to. The cost function is here. So basically, 1 is representing the first one is the origin. Boston is 1. The Cleveland is 1. Bradford 2. York is 3. And the second number on the x1, second under the x is the destination. 1 is Boston, 2 Chicago, St. Louis is 3, Lexington is 4. So basically, when we define our x variable x11 is from Cleveland to Boston, so therefore the cost corresponding to that is 3 per unit. So let me just type in all the parameter value I needed here to avoid later on we have some issues. So here will be 3, 2, 7, 6, 6, 5, 2, 3, 2, 5, 4, 5. Okay, double check everything is correctly. Okay, 3, 2, 7, 6, 3, 2, 7, 6, 6, 5, 2, 3, 6, 5, 2, 3, oops, 2, 5, 4, 5, 2, 5, 4, 5. Okay, so this is my first table. This is the only parameter we find. Okay, now table 2, choice decision variable. So it's measured by the unit shipped. Okay, unit shipped. So this is gonna be my choice variable. Okay, total 12 choice variable. And then I'm gonna creating this table, and everything in this table will be blank, as I said before, because the solver will help us fill in those blank. And the table 3, objective function. Cost. Okay, shipment cost. This is gonna equal to the unit was shipped times the unit from that origin to that destination. So basically, I'm using each unit we produce in that location origin. Each unit will be shipped from that one location to the other location and times the unit corresponding unit. Okay, so now this is my profit function I set up or correctly. Double check, make sure everything. So currently will be 0 because nothing fell in the decision variable yet. Okay, Now we're gonna go on to the constraint. So we totally have 6 constraints beside, seven constraints besides the non-negativity. So the first constraint is relative to Cleveland. They had the production constraint, right? The Cleveland. So we already, then the second constraint is related to the Bedford, and then York, and then those are the supply constraint. And on the demand, we also have constraint. Boston had constraint, Chicago, St. Louis, and then Lexington. Okay, so well, here. So this is my table for constraint. And then under here, we first talking about the unit actually either produced or sent to that location, an operator, and then the limit. Okay, so for the Cleveland, when we look at my answer, the constraint here, we just need to make sure x1 plus all those 4 x's smaller than or equal to 5,000. Okay, so this is equal to sum. This are representing my Boston's, and then so for this one has to, sorry, Cleveland, smaller and equal to 5,000. Next, Bradford is representing by this one, because everything starts with a 2, is representing starting from the Bradford. So for this one also need to be smaller and equal to 6,000. And then the York is the last one, starting with 3's. So this one also need to be smaller and equal to, the limit is 2,500. Okay, so now we finished the production, the production side, supply side. Now we're gonna go into the demand side. So for the demand side, we identify for the Boston X11, 21, 31 add together equal to 6,000, etc. Okay, so basically everything, every X ending with 1, so that representing from Boston. So this plus this plus, sorry, not that one. Ending with a 1. So this plus this. Oops. So this representing the Boston. So this has to equal to 6,000. Similar for Chicago, 2 plus anything start with the ending with a 2. Oops. So this has to be also, we just drag it down. This all equal to, this also equal to 4,000. And the next one, St. Louis, this is gonna be the one landing with 3's, ending with 3, 3. And then the last one is Lexington, also this ending with a 4, 4, 4. Okay, so this one is equal to 2,000. Lexington is 1,500. Okay, so those are my constraint, and also we'll have non-negativity constraint, right? Okay, after I set it up, and then I can use solver to solve it. Under the data tab, data analysis. Oh, sorry, no, can't. Sorry, data analysis. Under data tab, we'll click solver, and then my objective function. Click here. The object function is in table 3 here. And then here instead of maximum, it's minimum, minimize the cost, right? And my choice variable, click this little arrow, selecting the blank under my table 2. And then now we can add in constraints. Okay, since the first 3 are having the same operator sign, so I can select all 3 rows, first column together. And here is smaller than equal to, and I click the constraint for the limit. After that, we add. So for the destination, they all have the same sign, which equal sign, and the constraint, the upper limit is here. Click this. And after this, we finish all the constraints except non-activity, and we can click OK. Okay, so again, we only have 2 constraint listed here, but as you see, it's a multiple rows selected. So we here we totally have 7 constraints. And then we have non-negativity constraint selected, changing this to simplex LP. And after you do that, and then click solve. Okay. And then we can get an answer, sensitivity, limit. And then click OK. Okay, so now we are able to see our, let me go to the report. Okay, so the optimize, the minimize the cost here. Okay, so let's pay attention to minimize cost. So the minimum cost we will charge is $39,500. So that's the total cost. And this is the minimum amount cost we will have. So under this cost, in order to achieve this, we are sending 1,000 from Boston to one is Boston, and sending from Cleveland to Boston, 4,000 from Cleveland to what is the X12? Okay, X12 Cleveland to Chicago, and then we don't send anything from Cleveland to the other two center. And then from the second, which is second location, X2 is representing Bedford. Okay, for Bedford, we will ship the 2,500 Boston and 2,000 to the, what is the X23? X23 is St. Louis, so Bradford, so St. Louis. And then 24 is the 1,500 to, let's see, 24 Lexington. Okay. And then for the last, which is York, we send all of them to Boston. So by doing this, we're able to achieve the minimize the cost. And also we can look at Boston, Chicago, St. Louis, Lexington, all binding because that's how much they needed. So everything is binded. So that is the minimum cost will cost us.